This lesson we're going to continue simplifying radicals, but these radicals will not be perfect squares or perfect cubes. They will contain perfect factors. Let's look at two rules here. The product rule for radicals just states that if we had the same radical, like a square root, they're both square roots, or they're both cube roots, when we multiply, we can multiply what's under, or we can multiply the radicand together. And then with the quotient rule, the same applies with division. We can split the numerator and the denominator into two separate radicals. So our first example, we're going to get the square root of 2 times 3 is 6x. And for the second one, we're going to do the square root of 6 over the square root of 49. Square root of 6 contains no perfect factors. We leave it as the square root of 6. And square root of 49 is a perfect square, so we're going to change that to 7. Now, if we have radicals that are not perfect squares, then to simplify them, we're going to see if they contain any perfect factors. So a radical is simplified when the radicand, remember that's under the radical, contains no perfect factors. So you have to remember your perfect factors. So we have 1, 4, 16, I skipped 1, 9, 16, let me rewrite that. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, ... All right. So when we think about breaking this down into perfect square factors, you have to be careful that you get the largest perfect square factor. So what I would do is start from your larger numbers and work down. So we know on this list, obviously 25 and any number bigger is not going to work. So let's go to the next one down, such as 16. 16 is a factor because 16 times 2 is 32. So we're going to do the square root of 16 and the square root of 2. Well, since 16 is a perfect factor, the square root of it will be 4. And then since 2 has no perfect factors, we are going to leave it under the radical and we'll leave it as the square root of 2. So our answer here in simplified radical form is 4 square root of 2. The second example, we're going to bring the 5 down. We're going to break 75 into 25 times 3, because 25 times 3 is 75. Let's put each one under the radical. Bring your 5 in front down again. What is the square root of 25? Well, it is 5. We can't do anything with that square root of 3, so we bring it down. And now we're going to multiply these 5s together to get 25 square root of 3. Our third example here, we're going to split into the square root of 100 and the square root of x to the 5th. Now 100 is a perfect square, right? It's going to give us 10. Now when we think about our exponent here, 5 is not a multiple of 2. So what we're going to do, there's two ways to do this. We can break this down into what is the closest number to 5 that is a multiple of 2 without going over. Well, that would be the number 4. So I'm going to split these x's into x4 times x to the first, because if you remember your rules of exponent, when we multiply bases, we add exponents. So 4 plus 1 gives us this x5. We can now divide or split this into two individual radicals. So remember what we do is divide our radical into the exponents. So 2 will go into 4 evenly 2 times, and we'll leave that square root of x under the radical. Here we have the cube root. So I'm going to split this into the cube root of 16 and the cube root of y7. So this time we're thinking of perfect cubes. I'm going to list them the first 5. So that's 1, 8, 27, 64, and 125. Now 16 is not a perfect cube, but 16 does contain a factor that is, which is 8. 8 times 2 will give us 16. Now 3 will not go evenly into 7, so we're going to split this into y to the 6 times y to the first, because I want to split this into y6 because that's the closest multiple of 3 without going over 7, and I want these to add to 7. So now we can split these up into individual radicals. So we're going to start, all of the perfect cubes are going to go outside the radical. Anything not a perfect cube stays under. So the cube root of 8 is going to give us 2 on the outside. Our number cube root of 2 stays under. Cube root of y to the 6, 3 will go into 6 2 times evenly, so we'll have y2 on the outside. And then the cube root of y has to stay the y under the radical. Our fifth example, we're going to split this up. So we've got a negative on the outside. We've got the square root of 20, the square root of a to the 8, and the square root of b7. So we're going to break 20 down into 4 times 5 because 4 is a perfect factor. All right, 8, the middle one here, 8, 2 will go into 8 evenly. So this we do not need to break down anymore. But 2 will not go into 7, this b to the 7, it will not go evenly. So I'm going to break this down into b to the 6 times b. Our perfect factors are going to go outside. The ones that are not will stay under. So I'm just kind of writing some additional steps here that could be skipped. So we're going to get a negative. Square root of 4 is 2. The square root of 5, 5 stays under the radical. All right, a to the 8, square root of a to the 8, 2 will go into 8 4 times, even. All right, 2 will go into b to the 6, 2 will go into 6 3 times, that's out. And then the square root of b, that b has to stay under the radical. So let's do one more down here that I need to add. So let's do the cube root of 16 again. But this time let's just do like x to the 17. Okay, so we're going to break 16 down into the cube root, and the same thing with our variable. All right, cube root, we know 16 is 8 times 2. Now here, when we divide 3 into 17, it doesn't go even. So what is the closest multiple of 3 to 17 without going over 17? Well, that's going to be the number 15. So we're going to split this into x15 times, well, what does this exponent have to be to give us 17? Well, that means this one will be a 2 because we need these exponents here to add back to what we started with. I'm going to come over to the side. All right, let's just leave it, instead of splitting it, what is the cube root of 8? So the cube root of 8 is 2 on the outside. the cube root of this 2 can't go or stays under the radicals. Here we're going to divide 3 into 15. 3 goes into 15 5 times, even. And then here, this x squared, 3 will not go into the 2 evenly. It's smaller than 3, so that stays under our radical. So our final answer simplified would be this. I really don't need the space in between these two here. That's understood to be multiplication.